Good morning, all of you. Today we will discuss a very important topic in organic chemistry, and which is very important for the UG, PG students, CSI students, NET GATE students in our YouTube channel Hotspot Chemistry by Dr. Anil Kumar. The most important topic is how can you distinguish between 1 degree, 2 degree, 3 degree alcohol, that is primary, secondary and tertiary alcohol. So we can distinguish 1 degree, 2 degree, 3 degree alcohol by different four methods, that is Lucas test, oxidation method. Then another is number one is Lucas test, oxidation test. Then another is the Victor-Meyer test and copper heated methods. And one by one we will discuss all the things. Now it can be distinguished by how can you distinguish the primary alcohol. This is primary alcohol, it is known as ROH, and it is also as 1 degree alcohol. This is known as 1 degree alcohol, this is known as 2 degree alcohol, and this is known as 3 degree alcohol. And the example is CH3, CH2, CCH3, CH2OH, and there this is a primary alcohol, and this is CH3CH OH CH3. This is secondary alcohol, 2 degree alcohol, and it is CH3C CH3 OH CH3. This is known as a tertiary alcohol. Now, what is the Lucas test, and how by Lucas test how can you distinguish the 1 degree, 2 degree and 3 degree alcohol? In Lucas test, generally it is a mixture of conc HCl and anhydrous ZnCl2. That is called Lucas reagent, and it is denoted by a symbol LR. So at first of all, primary alcohol does not react with the Lucas reagent at room temperature, so no turbidity is formed. In primary alcohol, there is no turbidity at room temperature with liquid reagent by the reaction RCH2OH plus Lucas reagent. There is no reaction, therefore no turbidity is formed. Now in case of secondary alcohol reacts with Lucas reagent at room temperature. Turbidity appears in about 5 minutes. That is, turbidity comes within the 5 minutes. By the reaction RCHOH1 plus LR Lucas reagent, it will give R-CHCl plus H2. That is, turbidity appears within 5 minutes in case of secondary alcohol. While in case of tertiary alcohol, that is 3 degree alcohol, it reacts with Lucas reagent at room temperature. Turbidity appears immediately. In this case, turbidity comes immediately. By the reaction R-R-2COH plus Lucas reagent, it will give R-R-2CCl plus H2. That is, turbidity appears immediately in case of secondary alcohol. The main function in Lucas, in primary alcohol, no turbidity. In secondary alcohol, within 5 minutes, and in tertiary alcohol, turbidity comes immediately. Now, ready? Now, second test is oxidation. In presence of sodium Na2Cr2O7, that is acidified Na2Cr2O7. 1 degree alcohol on oxidation first yields an aldehyde. Remember, aldehyde, and further oxidation gives acid. So the main thing is, and all other main thing is, both the aldehyde and acid contain the same number of carbon. Remember this thing, same number of carbon as the original alcohol. By the example RCH2S, oxidation minus 2H, it will give RCH2, that is aldehyde, and with further oxidation it will give an acid with the same number of carbon as in presence of the alcohol. By the example CH3CH2H, on oxidation minus 2H, it will give CH3CH2, that is ethanol. With further oxidation it gives ethanoic acid, CH3COH. Here the number of carbon is same as in case of alcohol. Now, in case of 2 degree alcohol, on oxidation is first a ketone. Remember, first it will give a ketone with the same number of carbon atom as the original alcohol. But ketones are fairly difficult to oxidize, but on prolonged action of the oxidizing agent, ketones are oxidized to a mixture of acids, each containing lesser number of carbon atoms. Remember, lesser number of carbon atoms than the original alcohol. By the reaction RCHOH further oxidation in presence of Na2Cr2O7, it is RR-CO, which further oxidation gives RCOH, R1COH. By example CH3CH3CHOH, on oxidation it will give CH3CH3CO, that is propanone, with further oxidation CH3COH plus HCOH, that is ethanoic acid and formic acid. Propanol 2 on oxidation in presence of Na2Cr2O7, acidified Na2Cr2O7, it gives propanol, and further ethanoic acid and formic acid. but in case of 3-degree alcohol, 3-degree alcohol restricted to oxidation in neutral and alkaline medium, but are readily oxidized by acid oxidizing agent into a mixture of ketone and acid containing lesser number of carbon atoms than the original alcohol. So in presence of Na2Cr27, 3-degree alcohol, then no oxidation reaction occurs in case of 3-degree alcohol. So it means to say 1-degree alcohol and oxidation gives ethanol and ethanoic acid. 2nd degree on it will give propanol and ethanoic acid and formic acid, and there is no reaction in 3-degree alcohol. There is no oxidation occurs in presence of acidified Na2Cr27 in case of 3-degree alcohol. Test in Victor-Meyer test, and by very interesting, primary alcohol gives blood red color, secondary alcohol color blue color, and tertiary alcohol gives colorless. These are the things. In 3-degree this is colorless, in 2-degree this is blue, and this is in blood red. Primary alcohol gives blood red color. By the reaction RCH2S P/I2, it will give RCH2I, that is called iododerivative. In presence of AgNO2, it will give nitroalkane RCH2NO2, and further with oxidation with in presence of NaNO2HCl, it will give nitroleic acid, that is RCNO2 double bond NOH. This is called nitroleic acid. With further oxidation with NOH, it gives a blue color. That is primary alcohol with treatment of Victor-Meyer test gives blood red color. While secondary alcohol, that is 2-degree alcohol, RCHOHR, in presence of P/I2, it will give RCHI. This is called iododerivative, and in presence of AgNO2 it will give R2CHNO2, that is nitroalkane. Which further on in presence of NaNO2HCl or HNO2, it will give R2CNO2NO, that is called pseudonitrile, and with further treatment with alkali, that is NOH, it gives blue color. That is secondary alcohol gives with Victor-Meyer test blue color. And in case of tertiary alcohol is RRRCOH, that is P/I2 RRRCI. This is iodometric derivative. In presence of AgNO2, it will give R3CNO2, that is nitroalkane, which on further treatment with HNO2 in presence of NaNO2 and HCl, there is no action, and it gives colorless. That is tertiary alcohol on treatment treated with Victor-Meyer, it gives colorless. Secondary alcohol gives blue color, and primary alcohol will give deep blood red color. Now, 4th one is hot copper test. That is primary alcohol gives aldehyde, secondary alcohol gives ketone, and tertiary gives propene type. That is, as for example, RCH2OH in presence of copper 573 Kelvin, it gives aldehyde, that is RCHO plus H2. Secondary alcohol RCHOH in presence of copper at 573 Kelvin gives RCR double bond O, that is ketone. And in the tertiary alcohol CH3CCH3CH3OH, copper 573 Kelvin gives CH3C single bond CH3 double bond CH2 plus H2, that is it gives an alkaline. These are the different parameters by which we can distinguish 1-degree, 2-degree alcohol and 3-degree alcohol. And this is very important questions which generally comes in all the exams. So students are directed to prepare these questions answer properly, so that they get maximum marks in the coming exam. And this is the lucid examples, and a student can be benefited. So next day, a new video in our YouTube channel, Hot Spot Chemistry by Dr. Anil Kumar. Good luck and best of luck in the exam.